Hello, I'm Nick.
Hi, I'm Sujan.
Today we are demonstrating our application we created called MindStream. So essentially, MindStream is an AI-powered tool that can convert any spoken audio, such as lectures, brainstorming sessions, online meetings, and so on and so forth, into an interactive mind map.
Yep, so how exactly are we doing this and what were our goals for the project originally? So we wanted to be able to first input an audio clip, be able to transcribe that into straight text, and then finally pull that through make that go through an AI layer in the very end, convert that into a bunch of nodes and branches, and have a visual mind map that we could see that could be useful for all different areas. So then we also want our target to have about 95% accuracy when we translated from the speech to text and also establish the relationships correctly. And lastly, of course, we know the mind map isn't going to be 100% perfect because it is AI generated. So to be able to click and drag and annotate those nodes would be incredibly useful for all users.
Use cases.
So some of the use cases that we first started out with is mainly for individuals with cognitive disorders, ADHD, and people that are hard of hearing. So when they're in this meetings, they for some reason could not be paying attention that much, or just physically don't have the abilities to be paying attention. And for this reason, having this sort of summarized mind map towards the end of the meeting that they could look through, edit, and then visually process, because of course a lot of us are more visual learners than anything. So having that mind map could be extremely helpful for their learning and just understanding as a whole. And then throughout the hackathon, we realized that we could extend the use cases and the market audience to a variety of people. People in the corporate field, such as business and teams, and even people and students in academia that could be used for note taking, even during lectures and more use cases like that.
So here's some facts. For example, mind maps have shown a 30% increase in students' creativity, mainly because of the visual aspect. Children with ADHD who participated in training using mind maps made fewer mistakes on their tests. And mind maps can improve working memory and the recall of information for people with ADHD. Once again, because of the visual aspect that is introduced with mind maps.
Now let's take a deeper dive of the technology side and how actually we implemented this application.
So, generally speaking, our tech stack was created with a front end of JavaScript and React, which is how we interacted with our web components and developed the dynamic HTML web pages. Our back end is mainly managed through Python, Fast API, LangChain, and MCP. So with REST API calls to our database and our AI layers that we use to actually transcribe and create the flowcharts. For our AI, we use Gemini API.
Of course.
Thank you, Gemini, for sponsoring. And lastly, we use MongoDB with the AWS cloud server to host our mind maps, which we will get into later on for the demo.
So now for a look at our architecture. It can be a lot at first, but let's take a more deeper dive into this. So let's start at the top right. So we have our front end. So this is where users can, of course, upload their transcript and upload a recording or an MP3 file. And then from there, they actually have two options. We have the simple LLM, which is a simple LLM call to Gemini, but then we have a more complex agentic layer which utilizes, of course, LangChain and then model context protocols, allowing these LLMs to have various different tools to increase the quality of the mind map and the output as a whole at the very end. And of course, the output is also on the front end, and it just renders a mind map. So after a choice is clicked, again, two options. One is the smart mode and one is the fast API mode. And then both of these calls go through the Gemini, and then these are the tools, as you can see. So the tools for the MCP are extract structure, which is extract some plain text from the transcript that we made through the speech to text, and then merge maps, get memory, and then set memory. Having all these dynamic routes allow this agentic layer to have a higher level of reasoning and just a smarter understanding of the whole semantic understanding of the concepts when creating and structuring the mind map. And finally, after these mind maps are generated, we have a post request to MongoDB in order to store the mind maps. And of course, users can go back and see their mind maps after they have been generated. And again, the front end renders the graph, of course, at the very end. And we'll, of course, have a visual demonstration at the very end.
All right, and now we will be getting into our demo.
Okay, perfect.
All right, so this is our code base, which is where all the magic happens. As you can see there, we have a lot of files for both the front end, the back end, and how we started up is through a simple SH file that we created to boot everything up seamlessly.
Perfect. This is starting up. So once this is clicked, let's go to our local host. And that start script initializes both the front end and the back end. So this should be up and running. So do you want to talk about the
Yeah,
homepage a
sure.
little bit?
So this is where our landing page would be. So for our landing page, we can kind of have a summarized explanation of what MindStream is and some key features about what we can do with it and what it could be useful for. As you can see, we have a few options in our navigator bar, namely the gallery, the about, our mind maps, and the try it now button, which is where the meat of this project takes place. So just to show a quick demo, so the gallery kind of just shows for like users that first get on the page and they're curious about like what could be demonstrated, will be able to navigate to this page, which will show some example mind maps that they can click on and see what can be generated with our application. And if we go to the about, this kind of goes more in depth about our mission and what we can do with MindStream.
100%. It talks about, of course, the reason behind why we built this and the impact that we believe it will have on, of course, people of everyone, honestly, and especially people suffering from ADHD and just other disorders. And then, okay, let's just go ahead and try it. So let's go back to the home page. And then, of course, this is the mind maps area, which is where all the mind maps that we have previously been generated will be stored. So let's try it, and I'll hand it off to Nick.
All right. So we have two options inside of our graph generator. And you also notice that we also have a box for the type of AI mode we will want to use. So in this case, we'll start off with a voice recording. As we can see, you have the LLM and then the agentic AI. For this case, I will try using the classic because this won't be as long as the voice recording. It'll be more simplistic that I'll just demonstrate for our use cases here. So I will start. To start, you just click start recording, and then I'll just do a demo of like if I'm like at a corporate office meeting. Hello, good morning, everyone. I hope you had a good weekend. Today we are going to be looking over some tickets that we had before our major deployment on July 4th. Mainly, there's a few tickets for a few of our departments, mainly our back-end development team with Salesforce and CPQ, our front-end development team using Oracle ATG and jQuery and our database. Mainly, there's two tickets that we mainly want to look into. Mainly for the back-end development side, we want to look more into our account matching between our e-commerce website and our Salesforce website. And for the front end, we wanted to update the landing page for our e-commerce website. So once we finish the recording, it'll start transcribing. So if Sujin wants to go a little more in depth about what's happening behind the scenes while it's transcribing in terms of the AI.
Yeah, of course. So we used Assembly AI as our API in order to translate from speech to text. So React has a inbuilt web API, so we can easily gather our audio from the web page itself. But how did we actually get that audio into that TXT format that you see right there, the transcribed text? And that was through Assembly AI. We simply had a post request to Assembly AI with the audio, and then it returned a TXT. And we were surprised by how well of a job it did, actually. This is almost 100% perfect.
Very,
I'll be surprised.
Very accurate.
And then finally, we get this TXT, and this goes through the AI layer. I'll talk a little bit more about the AI layer. I did leave a little bit of a high level last time, but I'll do a little more in depth about how this actually works. So did we get let's check.
So as you can see, if we scroll down, we now have our generated mind map, which we can zoom in and out to, encompass everything that we can see.
Yep.
I don't know.
And then how is it in terms of quality based on what you were talking about?
It seems to look pretty accurate. If you can notice, so it starts off with a more high level overview of like what the meeting was about. In this case, it would be a meeting overview, and it kind of breaks it down in layers, and the AI actually determines like more like a hierarchical like base structure of like what is important and like it splits it apart into
Determines
its own.
relationships
Yes.
between what we were saying, which is incredibly cool.
Yes. So it goes from, we know that it's a pre-deployment ticket review, and it goes and actually breaks it into each type of tickets that we'll be dealing with, mainly the back end, the front end, and the database, which is what I mentioned. And it actually mentioned each specific use case or each specific ticket for each general team that we'd be working with. So it is very cool, and it would definitely help streamline a meeting for people that, we talk a lot. It's hard to, sometimes it's hard to keep up, and this can really help people that are in that situation.
And as mentioned previously, this is completely editable. You can drag, drop, move it around. Let's change database ticket to database Oracle tickets, just to be a little more specific in case, of course, a company uses Oracle as their legacy system. So perfect, they can just have that. And for anybody that missed the meeting or anyone who didn't have trouble during the meeting, they can just look at this mind map, get a simple overview over the action items, what they went over, just a understanding of what the meeting was about. So that's the first LLM. So the reason why we split it up into two different AI agentic structures is the first one actually does a really good job at very simple recording, stuff that's about 1 or 2 minutes. But when it gets very complex and the text is about 10 minutes, the context window isn't that good for just a simple LLM linear workflow. So this is where the agentic AI MCP comes in. So let me first go over to YouTube. So I found this example mock meeting that similar to just a corporate lifestyle. Talked about stuff to do, action items, the stuff that was in demand, what was due, and stuff like that. So I downloaded this as an MP3. As you can see, it's about 7 minutes. So of course, it's a lot longer than what Nick's recording was. So let's change this to the agentic AI mode. Perfect. So now instead of the recording, let's try the other ones. Let's upload the audio. Perfect, this MP3 file. And let that transcribe. So of course this will take a little bit longer because it is 7 minutes. So in the meantime, I could talk about the actual architecture for the agentic AI. So what we did is, yes, we do have a middleman, which is the agentic AI system, which is of course in the backbone, the Gemini LLM. And then with the Gemini LLM, it has access to about 4 resources and tools we could use. And the reason why we chose Model Context Protocol for our application is because the context window just didn't seem to be holding up throughout the entirety of our process. It would forget stuff. It would be the longer the duration of the video got, we saw an exponential decrease in the quality of the mind map itself. So it has about 4 tools that LLM can call on. It has extract a text. We can extract text. Actually, first, it chunks the different transcript into various different pieces. So we can chunk each one and process them chronologically, of course. And we have the extract text tool, which extracts the text chronologically. And then we have the merge nodes tool, which allows them to build the nodes separately, actually. And then when it finds the relationship throughout its reasoning process, it can establish that, of course, that parent-child relationship. And then it has set memory and get memory. So both of these allow the LLM to see what the mind map looks like currently. So of course it will build from the ground up. It can't build the whole thing all at once, especially for something as complex as a 10-minute video. And then from this, step by step, based on the reasoning capabilities of the model, it will call each different tool, and then from there, hopefully produce the high quality mind map. And we were extremely surprised and very happy with how this turned out. Let's see. Perfect. So as you can see, this is 7 minutes, so the mind map is a lot bigger, but it did a great job of finding all the relationships throughout the video, highlighting important stuff that were talked about, action items. So if we could even go to the right, there was actually an office party planning. So imagine you're the perspective of a person that missed the meeting they had a different obligation, and you wanted to see a meeting that was maybe 20 minutes, 15 minutes long. And we've all been in the same boat that we really don't want to watch the entire meeting. They could go over this mind map right here and see, oh, there's actually an office party planning. Let's see why. Oh, how are we doing the office party? Are they recruiting volunteers, minimum? All this can be seen in a blink of a second versus having to watch that 15 to 20 second video. Of course, again, people with cognitive disorders, with ADHD, that have trouble focusing, and people hard of hearing that really have a hard time picking just audio up. This is a perfect use case for them to help their life throughout.
Now, as we mentioned earlier, we also integrated a database with our mind maps. So let's say, for example, that someone generated a mind map and they happen to forget one of the keynotes, or they just don't have access to the recording any longer. Luckily, we actually have a persistent database which stores all of our databases associated with the user. So if you go to the mind map section here, as you can see, we have a bit more because we were testing, but it actually stores all of our data, or all of our mind maps that were created, whether it was used through the audio MP3 upload or through the live voice recording. So let's say, for example, we just noticed we did the audio recording of the Mind meeting with the volunteer notes. If we go to the latest one that was just uploaded, as you can see, it has exactly the same nodes and parents that we just witnessed a few minutes earlier. So yeah, that is mind maps or MindStream in a nutshell.
Of course, we can look at the other one that we did when Nick was talking, and as you can see, it's the exact same mind map that was produced. So yeah, this is pretty much our application. We had so much fun building it. Thank you for Gemini, all the sponsors of this competition. We had lots of fun, and we're excited to see what comes next.
Yep.
Of course, if you have any questions, just let us know, and thanks for watching the video.
Yep.